let's go ahead and go over number 1. So, 2 TVs are selected. Compute the probability that both work. I feel like maybe you guys need a tree for this, because people are having issues. So, it can either be defective or not, or good, right? What's the probability it's defective? 2 out of 7. What's the probability it's good? 5 out of 7. Now, let's take a look at the next one. Defective, good. Defective, good. We actually only care about, what do we want? We want to know the probability that both work. We want the good, good. Everybody on board with that part?
Yes.
So let's just not worry about that part. Let's focus on this part here. If I pick the TV, so if someone says, hey, there are 7 presents up here. You can pick 2. Would you pick 2 different presents to take home, or would you pick the same present twice?
2 different presents.
2 different presents. Do you guys understand what I'm saying? There are 7 TVs. You can have 2 of them. Would you pick the same one twice and just take that one home, or would you pick 2 different TVs and take them both home?
2 different TVs.
Does everyone understand that? So that's something that I'm going to expect you to understand and realize. That if someone says, pick 2, that you're probably going to want 2 different TVs and not just taking the same TV twice. Because I'd much rather have 2 TVs than just 1 TV. Everyone understand that? So here, when you pick a TV, then now I picked a good one. How many are left?
6.
6. So they're both going to be out of 6. How many are good?
4.
4. How many are defective? Still 2. Does everybody understand that?
Yeah.
I want to know how to get here. So I'm going to multiply 5/7 times 4/6. So this is going to be 5/7 times 4/6. What do you guys get?
0.476.
0.476. Is that right? Has someone else got? Great. Okay, now, find the probability that at least 1 does not work. This is why I didn't want you wasting forever on this problem. You guys spent way too much time on this problem. At least 1 does not work. It's 1 minus the probability that, okay, so at least 1. Instead of at least 1, you're going to write the word, because it's 1 minus, none. The complement of at least 1 is none. Everybody understand that?
Yeah.
And then, you're just going to write whatever comes next verbatim. Does not work. You're just going to copy those exact same words without changing anything. Does not work. Then, you have to think about it. If none do not work, I have 2 none don't work. What does that mean if none don't work? They all work. Does that make sense?
Yeah.
And you have to go through that whole thing of like, what the heck? None don't work. None don't work. None are broken. None are broken. Oh, they both are good. Right? But you have to go through that step of like figuring out what that weird English is of like the double negative stuff, right? So both do work. So that means that that's the same thing as 1 minus the probability that both work. And you already have that. 1 minus 0.476. 0.524. All right, take a minute, talk to your neighbors about it. Or 30 seconds, go.
Because then if we did that means that we notify computers because
Yeah, but there's different answers. No, that's number 1.
oh yeah, this here is my number 1. Now we're working on this one. So like 1 minus 0.46, which is what we have here.
Yeah, but I don't know how should pick 4 over 6.
You don't know what should I what?
No, I don't. Okay, I understand.
You get it?
Yeah.
let's move on to number 3. If I can find it.
Wait, don't we have to solve what
Okay,
is?
so I want you guys to draw a tree for this. The first event is gender. So let's see, let me get my tree. We've got men and women. And then, so what's probably like we have that that we pick a guy. 34 out of 58. Probably pick a woman. 24 out of 58. Great. If we're standing here with the men, how many people are there? 34 of them. So now everything's out of 34. Do you guys see what I'm saying?
Yeah.
If we went that way, there's 34 people. If we went this way, there's 24. So now everything's out of those 24. Where do those 24 go? Some went there, someone went there, someone went there. So then you have your sport. Oops. Your sport. Soccer, basketball, tennis. And out of these 34 men, how many went to soccer? 16 out of 34. Make sense? Because you know that they're just these 34 men. So it's these 34 men. 16 out of 34. Basketball, 15 out of 34. Tennis, 3 out of 34. What about the women?
11 over
Okay, I'm going to give you guys 1 minute to sort out the women if you haven't sorted out the women yet. Do that one.
14,
And then try to answer the question.
and then poetry, and then basketball, so it'll be 34 out of 15 times 15 over 34. And
All right, so let's take a look at this one. Women, soccer, basketball, tennis. There's 24 women. How many play soccer? 11 out of those 24. How many play basketball? 4 out of those 24. And then 9 out of the 24. Great. Now, probability of soccer given women. Given women means what's the probability that they're a woman? 100%. I'm giving you that information. Given they're women means 100% they're women. So 100% you are standing right here. If you're standing right here, then what's the probability that they are playing, was it soccer? 11 out of 24. Does everybody follow that part? Good. Expect you all to get that right on the exam. 11 out of 24. From your tree, find the probability of men and basketball. So men and basketball means you want to end up right, men and basketball right here. How do you get right there? 34 over 58 times 15 over 34. Oh look, 34 over 34, those cancel out. And you get 15 over 58. Everybody see that? 15 over 58. Find the probability of men in basketball just from looking at the table. So looking at the table, how many men play basketball? 15 out of 58. Look how beautiful that is. Isn't that amazing? It is gorgeous. How would it change if in the first event was sport, then it used to be like soccer, basketball, tennis, and then your second thing would be man, woman, man, woman, man, woman. But you get the same thing. The only difference is that you'd be out of, it'd be, the fractions might be different, but in the end they still cancel out. Okay. let's, I'm gonna give you guys 2 minutes to work on problem number 2.